These are the examples for Geometry B, Credit 3, Lesson 15.4. Lesson 15.4, we're going to continue working with circles, and we're going to talk about a few different theorems here, intersecting chords, the secant theorem, sometimes called, and then over here, secant tangent. So first of all, for problems 1 and 2, we have two intersecting chords. Now, what they want us to do is find the measure of this segment here, which is called x. So this is 5. This is represented by x. This is 10. This is 12. And so I always find this interesting. Someone at some point discovered that when you have intersecting chords, and in fact, let's back up a little bit. A chord, remember, is just a segment that's inside of a circle that connects 2 points on a circle. A chord could be a diameter, but we're not told that either one of these chords is a diameter. It would be a diameter if it went through the center of the circle. But that's kind of neither here nor there. That's not what's the most important thing here. So what we do here is we want to find x. It turns out that the product, and remember product just means multiply, the product of the segments of one chord is equal to the product, multiply, of the segments of the other chord. So let's show you how that works out. So we've got 5 times x, or 5x, equals 10 times 12. And that's how we set up our equation to solve for x. So over here on the right, we can simplify that. 10 times 12 is 120. And then our final step, we're focused over here on the left because that's where x is. X is being multiplied by 5. So we divide 5 to both sides. And it turns out that 120 divided by 5 is 24. And so our answer, x is 24. All right, next is our secant theorem. So what is a secant? So let's go ahead and put these words up here. So a chord, remember, is a segment, well, I'll just put chord, is a segment that connects 2 points on a circle. Now, if that chord gets some energy and runs outside the circle, it goes through the circle, we call that a secant. And so what we have here are two secants, and we're going to see how we're going to use the information to solve for x. Now, based on what we did for 1 and 2, this might not be what you think. A lot of times things are intuitive, but not probably in this case. All right, so here's how we set this up. So for each secant segment, and we are going to set up an equation. So we're going to have something from this segment and something from this segment that will be equal to each other. But how we set that up is a little bit different than what we did here. So what it is, it's the outside part, the 10, times the length, not the inside, but the length of the entire segment, which would be x plus 10. And so 10 times the sum of x plus 10. So 10 times the whole thing. So that's why we have to put parentheses around it. And now we're going to do the same thing over here. The outside part, the 5, times the length of the entire thing, which would be 25 plus 5. So 25 plus 5. All right, so now we can start doing some simplifying. Over here on the left, we can distribute that 10. So we have 10 times x, and then 10 times 10. Let's go ahead and just set that up like that because we're going to have to do a little simplifying over here. First thing we're going to do here, order of operations. Well, we could distribute, but we could also follow the order of operations. Work what's in the parentheses. 25 plus 5 is 30. And now let's go ahead and simplify these multiplications here. 10 times 10 is 100. And then 5 times 30 is 150. All right, so just 2 more steps. We're focused over here on the left because that's where x is. We need to get rid of the 100 and then get rid of the 10. Addition and subtraction is we always undo that first. The opposite of adding 100 is to subtract 100 to both sides. The hundreds cancel. We bring down that 10x. and 150 minus 100 is 50. Last step, x is being multiplied by 10. So we divide 10 to both sides. The 10s cancel out, and 50 divided by 10 gives us 5. And so our answer for our example for 3 and 4 is 5. By the way, for 1 and 2, it's pretty much oriented the same. 3 and 4, kind of the same, but same principle regardless of how, if the lines are drawn like this or like this. So that's secant, a couple secants there. All right, now, in our last example, for problems 5 and 6, we have two things going on here. We have a secant again. Remember from a previous lesson, a line that just touches the circle is called a tangent. So this is secant tangent. So once again, we're going to have an equation from the secant and then from the tangent. We'll explain how to deal with the tangent. The secant's the same thing we did on the previous example. So it's the outside part, the 20, times the length of the entire secant, which would be x plus 20. So that's what's going to go inside the parentheses. Now over here, we only have one measurement, the 30. And so the way we handle that is we multiply it by itself. So whatever the length of the tangent is from the vertex here to where it touches the circle, we just take that number and square it. So 30 squared. In other words, multiply it by itself. All right, so let's go ahead and start doing our work here. We're going to distribute the 20. 20 times x is 20x. And then 20 times 20, let's go ahead and just multiply that now. So we have 20 times 20. That's a little sloppy there, which is just 400. So that's how we got the 400, 20 times 20. Over here, 30 squared, which means 30 times 30 is 900. And now we're ready to solve for x, or continue to solve for x. So x is over here on the left, so we're focused on the left. We got to get rid of the 400, and then we have to get rid of the 20. The opposite of adding 400 is to subtract 400 to both sides. 400s cancel out. We bring down the 20x. Over here, 900 minus 400 is 500. And then our last step, x is being multiplied by 20. So we divide 20 to both sides. 20s cancel out over here. That's the whole reason why we divide by 20, of course. And then over here, 500 divided by 20 would be, or is, 25. And so that is our example, our answer in our example for problems 5 and 6. And that's it for lesson 15.4. So again, let's go ahead and get all the examples in the frame, as we sometimes like to do, so you can pause and study those. All right, so that's it for 15.4. Pause, rewind the videos as needed, and I'm sure you'll do great with the work. And until the next video, take care and God bless.